All right. So, thank you for coming to today's live session of solving the problems on AMC book. So the specific session is called the AMC 8 100 Tricky Problem Solving Session. Okay, and for this week, our focus is on number 3. So I will start from where I left out last time. So there is a small thing to talk about. So during our last live stream, there was like a technique issue, so I wasn't able to finish. I wasn't able to share the screen of, I think, exercise 3 warm up. So it's basically this problem. So today, I will start from this problem. Okay. So the problem says that Z be a 4-digit positive integer such as 5,353, whose first digits are the same as its last 2 digits. Okay. So let's highlight the key point. It's saying the first 2 digits are the same as the last 2 digits taken in the same order. Okay, so what is the smallest prime factor of Z that is not less than 50? So this is a problem adapted from 2017 AMC exam. Okay, so basically we changed the number, but originally this is a real problem. So let's try to start our first step. That's basically saying Z is equal to, since it's 4-digit, we can use each letter to denote 1 digit. So let's put a bar on top of it so we know this is a 4-digit number. And we can put it into the form of 1000 times A plus 100 times B plus 10 times A plus 1 times C, which is B. The reason why we can do this is because we know the first A is the thousandth digit. Okay, so we multiply that letter by 1,000. And the first letter B is the 100th digit. Okay, so when we put these numbers into these digit into a number, we can multiply 100 to the letter B. And same idea for A, the second A is the 10th digit. So it's 10 multiplied by A. And finally, the single digit, the unit digit is B. So that's how we come out with the addition. Okay. Now, let's try to observe that we have, let me change the color. Okay. We have A here and A here. And also we have B here and B here. These are some common terms. Okay. So we can apply the distributive law of multiplication. Okay. Now, when we combine all the terms that has A within it, we can have 1,010A plus when there's 100B plus another B, we get 101B. Okay. Now let's take 101 as the common factor. Okay. So 101 times 10A is now representing the first term from the previous step, then plus. Just copy down 101B, okay? Now, again, we have the same term, same number appear in both terms. What is a number? Is 101, okay? Now, what should we do? We should apply the distributive law for the second time. So we put 101 outside the bracket times whatever is inside, okay? So 10 times A plus, here we are left in with a B, okay? So that's our fourth step, and we can put into the format of 101 times 10A plus B. It's basically A, B with a bar on top of it to denote that it's a 2-digit number. So let's get back to the question to see what it's really asking. It's asking for what is the smallest prime factor of z. Okay, so to find the smallest prime factor of z, now we have already put z into factors form, where one factor is 101 and the other factor is AB. Okay, so there's a requirement. So let me put the factorization here. So this is our first step in color blue, and now I will use green to denote the second step. Okay, now the two factors of z is 101 and AB. Okay, so let's try to make AB the smallest prime factor. And there's another restriction on the value of AB. What is that? Is it cannot be less than 50. So let's start with 50 and to see what is the first prime number we get after 50. Okay, so let me write down the thinking. So it's saying we need AB, this double-digit number, to be no less than 50. No less than 50. Okay, good. Now, there are some possible numbers for AB starting from 50. So the first thing is 50 a prime number? Again, the definition of a prime number is that the only factor of that number is 1 and itself. So obviously, we can find another pair of factors besides 1 and 50, right? How about 5 times 10? It gives you 50, right? So from here, we know that this is not the prime number we are looking for. So 50 is eliminated. How about let's try the second number after 50, which is 51. So I propose that 51 has factors to be 3 and 17. Okay, so these are factors that are other than 1 and 51. So we know that 51 is not prime. Okay. Oh, sorry. Let me go back. Okay, good. So let me put a little cross to denote that this value is not the one we're looking for. How about 52? There's even no need to consider 52, but 52 is an even number. So any even number except 2 itself, it must have its factor to be 2, right? 2 is always one of its factors. So this is definitely not prime. So I can still write it down. When we do 2 as one of a factor, the other factor should be 26, all right? So there should be a red cross for this number as well. A red cross. Okay. Now, how about the number after 52? So where's my pen? I get my pen ready. So after 52, we should have 53. Okay. So can you think about a pair of factors that is other than 1 and 53 itself? So how about 2? This is an odd number, so 2 cannot. So this cannot be a multiple of 2. How about 3? So the feature that a number can be perfect divided by 3 is that when you add up all the digits of that number, it should be a multiple of 3. So in this case, we have 5 and 3. That's 8. 8 is not a multiple of 3, so the number itself, 53, cannot be divided by 3. Okay. Is it a factor of 4 possible? No, because it's an odd number. Okay. Is 5 a possible factor? Nope, because for all the numbers that can be divided by 5 without a remainder, it must have the last digit to be either 0 or 5. Okay, that's something you can always observe the number. So 5 doesn't work, and 6, 7 doesn't work. So we know that 53 is actually prime. So that's the number we are looking for. Okay, so the only factors of this number is 1 and itself, which satisfy the definition of being prime. So let me put a check mark to distinguish 53 from all the numbers we just had previously. So what is the solution for this one? A, B, C, D, E. It should be B, right? So the smallest prime factor of Z is 53. So let's circle the correct answer. All right. So that's for this problem. And we can really do a quick review of how we start the solution. The first thing we do is what? Is to write down the number by digit. Okay, then you want to consider which letter correspond to the thousandth digit, to the hundredth digit, to the 10th digit, and the unit digit. Just write it out. Okay, then we are doing prime factorization. Good. So let's move on to the second part. Okay, so where's my pen? Okay, I'll get my pen ready. So now this is another problem. It should follow the exact same approach of thinking because the previous one is a warm-up and this is a problem derived from a real AMC exam. Okay, So let z be a 6-digit positive integer, or I'll pause for a second. Okay, so let me change that real quick. Okay, so it looks like I have a technical issue. Let me change the YouTube. Okay, so where's my YouTube? Let me pause that. Okay, now it should be working. Okay, now it should be working. Originally, I thought I was talking to the black screen. Okay, so let me put on a chat box. Is the screen still black? All right. Now, if it's still black, you can tell me. No, okay. So now it's working fine. Okay. For the first problem, I will upload my notes. Okay. So sorry for the inconvenience. Let's get back to the second problem. All right. So the second problem is talks about let z be a 6-digit positive integer. Okay, such as 247. So you can see there is some interesting feature about this kind of 6-digit numbers, and it's asking for the first 3 digit are the same as its last 3 digit. Okay, taking the same order. So which of the following numbers must also be a factor of z? So remember, when we have a question asking you to find like a 3-digit number, a 5-digit number, or a like 6-digit number, we can always write down the number by using letters to stand for each of its digit. Okay, so our first step, I will say, let's suppose the number is z. Okay, and it can be written as a b c a b c. So the reason why we put ABC, ABC is because we are told that these numbers, first 3 digits, are the same as the last 3 digits. So there should be a bar on top of this number. And let's try to identify what is the unit digit, what is the 10th digit, what is the 100 digit, what is the 1,000 digit, and so on. Okay. So the first A, we should have 1, 2, 3, 4, 5 digit after it. So we can put into 10,000. Oh, it actually is 100,000. Okay, 50 after it. 100,000 times A plus. How about B? We should have 1, 2, 3, 4 digits after it. So we should have 10,000 times B. Okay. How about C? C is the 1,000th digit. So clearly 1,000 times C is needed for here. And for the second letter A, so now A is 100th digit, which means we need to put 100 multiply A. And how about B? B is a 10th digit, so just 10B plus, okay, C is a unit digit, it's 1 times C, which is just C. So let's first identify which term is consists of which letter. So it looks like the first term, we have letter A in it. Also, the third term coming from the right, we have A in it. And the second term, we have B in it, okay? And also the second term counting from the right-hand side have B. And finally, the third term, we have C. And the last term, oh, let me change the color actually. So the third term, I'll use red, we have C. And also the last term, we have C. Okay, so we have now paired up all the common factors. Let's apply distributive law of multiplication. Okay, good. So let's do it step by step. I'll put an equal sign. And we should combine those terms with A inside. So we should have now, okay, so it's 100,000 and 100A plus, how about B? So it's a 10,000 B plus 10 B, so it's a 10,000 and 10 B, okay? How about C? It's 1,000 C plus another C, so in total it should be 1,001 C. Now, let's do one more step to make this one even simpler. Do another step of simplification. It should give you 1,001 times 100A, okay? If you multiply by these two numbers, you should get exact same result as above. And the second term now becomes 1,001 times I will keep consistent using the dot multiplication sign, okay? So we should have 1001 times how many b? 10b, okay? And the last term is easy, just 1001 times c, nothing changed. So what can we observe here? We have 1001 in the first term, 1001 in the second term, and also 1001 on the third term. Good. So we can again apply what rule? The distributive law, okay? So distributive law, one more time. We pull out the common number, which is 1001, and whatever left over should be put into the bracket. So the first terms, we are leaving out 100A, and the second term, we are leaving out 10B. A third term, we're leaving out just C, okay? So in this case, we should have 1001 times, so 100A, 10B plus C, you should put into A, B, C as a 3-digit numbers, okay? You put a little bar, horizontal bar above it to denote that it's a number. Now, so let's get back to the question, what's really asking for. It's asking for which of the following numbers must also be a factor of z. So it's really asking for what are the factors of 1001, okay? So if it's a factor of 1001 and 1001 is a factor of the number z, then the factor itself should be a factor of number z, okay? It sounds a little bit weird, but that's how we work on problem like this. So we're asking for what is the factor of z. So factor of z is our interest. So let's try to do a prime factorization of what number? 1001, okay? So I will start on the right-hand side of the screen. So let me change the color to denote it as our next step. So we first put 1001 here. Let's think about what are the factors we can start with. So 2, it doesn't work, it's odd number. 3, again, so for a number to be perfectly divided by 3 without any remainder, we must have all digits add up to be a multiple of 3. So 1 plus 0 plus 0 plus 1 is 2. 2 is not a multiple of 3, so it doesn't work. 4 doesn't work, obviously. 5, the last digit is not 5, not 0, so it doesn't work. 6 doesn't work. How about 7? Let's try 7. So if I put 7 here, you can also try the calculation on your notes, okay? We should be living with 143, okay? Then 143, let's observe the number. How about I write 143 as what? As 110 plus 33, okay? When I put the number in this way, it should be rather clear that 110, okay, is a multiple of 11. 33, good, it's also a multiple of 11. So these two numbers add up. It should be a multiple of 11. So let's put 11 as our second prime factor. We are living with, so 110 divided by 11 is 10. 33 divided by 11 is 3, so 10 plus 3, we are having the number 13. And we know that 13 is what? The prime number. So basically we're done. So let's get back to the question. Which of the following number must be a factor? Is 11 one of the factors of 1001? Yes. So let's finish reading all the options. 19, okay, 19 doesn't appear in the list of 7, 11, 13. So 19 is crossed out, 101, it doesn't appear as one of these three numbers. And same thing for option D and E. So clearly, we should choose option A, okay? So for this kind of problem still, the first step, write out the number digit by digit, okay? Put into ABC where one letter corresponds to one digit. Then understand which number is the hundredth digit, the thousandth digit, the tenth digit, and the unit digit. Write it out like addition of the corresponding number. For example, the 1,000 digit is just 1,000 times the letter. 100 digit is 100 times the letter. And usually we are going to apply the distributive law. And the final step is most commonly the prime factorization. Okay, that's for our second problem for today. Let's get back to the screen. Let me select my mouse. Okay, it's right here. All right, so for the next slide, let me zoom out a little bit. There is a quick information I would like to share with you. Okay, good. 好，首先欢迎大家来到我们的直播间。 今天我们讲的是书论，好，欢迎大家。特别想跟大家讲一下，就是大家可以看到前面2道题呢，它实际上是来源于我手里的这本书，也就是我们的 AMC 8 book，中文叫 AMC 8大宝典。这本书它在编撰的时候呢，它其实是作为一个给小朋友提供便捷的一个题库去考虑的，所以它上面的题它包含了100加道易错题，给翻开给大家看看。你看它里面是这个样子，然后有50加到近10年的高频考点。同时，它的题目有一个非常好的地方，就是它是按照6大模块，就是几何、算术、应用、代数技术、统计这些去进行分类的，然后就非常适合小朋友在考前，比如说，我哪一个模块需要专门强化一下，就可以打开这本书，然后按照目录找到那个模块进行专项练习，非常节省时间，然后在家随时就可以学。这本书售价是$59，但是我们现在有活动，可以让你免费获得一本，就是跟我手里这个一模一样的纸质版本。如果您是新生的话，也就是说您之前孩子没有在 Think 上过课，那您可以添加屏幕下方的微信，就是这个 ThinkVIP60，也就是我的微信，然后我会协助您去选择适合孩子的体验课。然后当孩子完成这节体验课之后呢，我们就会有客服老师把这本纸质版的 AMC 8大宝典寄送到您的地址。OK， 这是对于新生的领取方式。然后对于老生的领取方式呢，如果孩子目前是我们 G4、G5 竞赛长期班的学员，那我们应该已经把这本书作为福利发送给大家。如果您还没有收到，也非常欢迎您添加下方这个 ThinkVIP60 的微信号，然后我会尽快协助您获取这本书。好的，然后这就是关于我们这个 information session 的一些内容。Let's get back to the problem solving part, okay? All right, so exit ticket. So exit ticket is the problem that testing on your ability of solving problems really similar but a little bit more challenging, like the real AMC problem and the warm-up. Okay, so basically we are going to use the same approach, the same technique. So the question is asking for how many of the digit in 1, 2, 3, 4, 5, 6, 7, 8, the number are factors of the number. Okay, so I know the question itself, it may be a little bit confusing to understand. So let me do a quick clarification. So when asking for the question, we are actually looking for all the digits from 1 to 9. Okay, so it's 1, 2, 3, 4, all the way to 9. And in between, among these digits, okay, what are factors of 1 to 9, the number? So let me first write down the range that we are looking for. So all digits is from where? 1 to 9. Okay, good. So now obviously we can eliminate one of the option. So option A says 0. So from 1 to 9, at least 1, it must be a factor of the number. 1 is a factor of any whole positive number. Okay, so we can actually eliminate A already. So the second thing we want to do is to observe the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the number that appears on the last digit? Okay, it's 9, right? So 9 is an odd number. In order for a number to be able to divide it by 2, it must be an even number. Okay, by 4, it must be an even number. By 6, it needs to be an even number. Okay. By 6, it also needs to be an even number, because you can think about the first multiple of 6 is 6, and it's 12, that's 18, 24, and 30, 36. You can never appear with a odd number on the last digit when you are divided by an even digit. So then we can conclude that we are going to eliminate all even digit due to the fact the last digit of a number is 9, an odd number. So let's write down first step. So first step is eliminate all what digit? Even digit. Okay, so I will change my color. We're going to eliminate all even digits. So we have already eliminated half of the numbers from 1 to 9, right? Good. So now what numbers are left? I will go back to color blue. So the numbers are left is we now have 1, 3, 5, 7, and lastly 9. Okay, so these are the numbers that are still left for our consideration. So let's do it in the second step. We're going to check each of these numbers one by one. Okay, by the way, for now, how many numbers are we left? 5 numbers. So Option D is eliminate. It can never be 7, okay, after the even numbers are out. So let's do the second step. I will put a little 2 here to denote the second step. We know that 1 must be a factor, okay, so let's put it here. 1 must be a factor for any positive whole number. Must be a factor. Good. Now, the second number we are working on is 3. And how about let's put numbers 3 and 9 into one case. I propose that 3 and 9, both numbers are factors. Okay, I will explain that reasoning shortly. Let me first complete my writing. 9 and 3 are factors. What is the reasoning behind? So as I said, in order for a number to be able to be divided by 3 or 9, first we need to add up all the digits of that number. So in this case, we add up all the digits. It should be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Okay, so these are all the digits. And what is the summation of all these numbers? So if you calculate correctly, you should be able to have the same result as me, okay? So it's 45. Then let's observe the number 45. Is 45 a multiple of 3? Yes, 3 times 15 is 45. And is 45 a multiple of 9? Yes, 5 times 9 is 45. So we observe that 45 can be divided by both 3 and 9, okay? Can be divided by both 3 and 9. Okay, 3 and 9. Good. So since 45 can be divided by both 3 and 9, the number itself should be a multiple of 3 and 9. So 3 and 9 are factors that put check marks under these two numbers. Okay, then we are doing a very simple number, which is 5. Why I call 5 a simple number? Because as I mentioned previously, in order for a number to be a multiple of 5, we must have its last digit to be 5 or 0. Obviously, the last digit is 9, not 5 or 0. So 5 cannot be a factor. I will put a red color here to denote an eliminated number. So 5 cannot be a factor. So let me go back to blue. 5 cannot. Okay, cannot be a factor. And the reasoning is last digit. I will keep it short. Okay, so last digit is not 0 or 5. Okay, last digit is 9. Take a look, last digit is 9. So 5 is out. Let me put a little cross mark under that. Okay, so 5 is gone. So now actually we are able to get the right option selected already. Since 5 is out, we are left with 1, 3, and 9. So the possible number is either 3 or 4. So we take a look of the options we are given. So it cannot be 5, right? 5 is out, so we're only left with 4 numbers. Then if we apply the method of elimination, we should know we are choosing option B. Okay, so which means 7 is also not a factor of that number. Okay, so this is a quick trick you can apply when you're actually in the exam. When you know among the 4 options, 3 of them are incorrect, then the last one, which are left, must be the correct answer. This will give you a more speedy way to solve the question. But we can take this question as a fill in the blank, and we can actually divide the number by 7 to test it out. So unlike number 3 or 9, where it's an easy way to quickly determine if a number is a multiple of these two numbers, if we want to test out if a number can be perfectly divided by 7, there are some kind of rules you can apply. For example, remove the last digit and minus the original number, remaining numbers, minus the last digit from the remaining numbers and square something. But the rule is kind of complicated. I recommend you to just try that. Okay, divide the number by 7 to see. And in this case, I tried that myself, and 7 cannot be a factor. Okay, wait, I'm shifting my screen all the time. So I will keep red to be consistent. So 7 cannot be a factor. 7 cannot be a factor. Cannot be a factor. So the only factors are 1, 3, and 9. 5 and 7 are not. So we are choosing how many? 1, 3, and 9, 3 numbers. So option B. Okay, that's for this problem. And we are going to try a problem that's still in number theory, but use a different approach. So warm up. It's asking for what is the sum. So let me highlight the keywords here. Is the keyword sum. Can I zoom in a little bit? Okay, good. So what is the sum of the distinct prime factors? So by saying the word distinct, we are referring to the fact that we are only counting those numbers appears once. So for example, not appear once, only those numbers, if for example 2 is a prime factor and appears several times, we only add it once. So that's the word distinct referring to, okay? So let's be clear on that. So the first step is always what? In order to add up all the prime factors, we first need to know what are the prime factors, right? That's a straightforward thinking. So perform prime factorization, okay, how to spell factorization? Factorization. On which number? On 2024, okay? So this should be 2024. Let's observe the number. It's even, right? So what is the first prime factor you should consider when given an even number? You should do 2, okay? So we are left out with 1012. Then divided by 2 again, because the last digit is 2, which is also even. So we have 506. 6 is an even number, divided by 2 again. Then we should have no longer even but an odd number, 253. So is this a prime number? Let's check. Clearly it's an odd number, so no way to divide that number by 2. And let's first rewrite that number. And also there's no way to divide by 3, remember? Because the summation of the digit, 2 plus 5 plus 3 is how many? It's 10, right? 10 is not a multiple of 3. So let's rewrite this number into what? Let me change the color. So where's my pen? Okay. We can put this number into the summation format of 220 plus, what is the part we need to plus? 33, right? So now it should be way clear that 220 is a multiple of 11 as it has repeating digit. When you have repeating digit, you want to think about factor 11, okay? And 33 is also a factor of 11. So let's try 11 as our next prime factor. I got my pen ready. So 253 divided by 11, the result is 23. Obviously, 23 is a prime number. So at this point, we know we are finished with the factorization procedure. So I will put an arrow here and put the word prime. So we know that we are done with the factorization. Now, let's do the let's solve the problem. What is the summation of distinct prime numbers? So the first distinct prime number we have is 2. Although it appears 3 times, but we are only doing 1 because we're asking for distinct. So let me get my pen in blue again. So the first number is 2. Then we are adding by 1 number. The second distinct prime factor is 11. And the last one is 23. Okay, so 2 plus 11, 13. 13 plus 26 is how many? It's 36. So I'll put a little box to denote that's our final answer. And we should choose option B. Okay, so this is a very straightforward question, right? Asking for the sum of prime factor. First step, determine what are the factors. Then be careful with the word distinct. Other than that, there shouldn't be much more challenging stuff here, all right? Okay, before we move on, let's do a quick information session. 好的再次欢迎刚到直播间的大家，还有正在观看直播的大家。大家可以看到，我现在手里有一本这样的书，这个书就叫我们的 AMC 8 Book， 也就是我们 AMC 8大宝典。刚才您看到的所有题目都来自于这个书最后一个章节，叫做100 AMC Tricky Problem， 也就是 AMC 8难题100道。这本书它在编撰的时候，它收录了100多道的易错题，同时还有近50多道近10年的高频考点，所以可以说是非常适合于比如说正在备考2025年1月 AMC 8考试的小朋友去拿来练习。 同时呢，这个上面的题目它其实是按照模块进行分类的。您可以在这本书的目录上找到几何算术、应用、代数统计和计数这样的6大模块。然后在考前，比如说小朋友想进行某个模块的专项强化，那这本书就更加适合了，他可以直接翻到这个模块去做这个模块的题，非常节省时间比做整套模考来说。然后这本书原价是$59，现在我们做活动，只要您分为2类如果您的孩子是新生，还没有上过我们分析的课程，那么您可以添加屏幕下方的微信，也就是这个 thinkvip60，然后添加完微信之后呢，我会帮助您去报名适合孩子目前水平的$1体验课，本身这也是个福利。然后完成体验课之后，您就会收到一本这样跟我手里一模一样的纸质版大宝典，我给翻开大家看看，它里面这个样子。好的，然后如果您的孩子是我们的老生，然后对于 G4、G5 的竞赛学员的话，我们应该已经完成了发送。然后如果您还没有收到的话，那也非常欢迎您添加屏幕下方的微信 thinkvip60，我也会协助您去尽快取得这本宝典。好的，然后特别要注明一下，我们这个活动目前仅限小高年级，也就是开学到 Grade 3 to 5开学暑期结束，开学3到5年级的小朋友。好的 let's get back to our problem solving part of the live stream. Good. So the next problem we should have, including this one, we should have 4 more to go for today's session. Okay. So what is the sum of the distinct prime integer divisor of 2016? You can see this is the one that really similar to the last one. So let's apply the same technique we just used. Starting from the first step is what? First step, okay, for this kind of question is always perform prime number factorization. Prime factorization. Good. So on which number? On 2016, okay? So 2016, since this is an even number, so always try to divide by 2 when given an even number. We should be ending up with a quotient of 1008, still even number. So let's repeat our previous step, divided by 2 again. We should end up with another even number, 504 divided by 2 again. Then 252 is our next even number. Continue our procedure of divided by 2. We should get which number? 126. Is this number even? 6 is even. So let's divide by 2 one more time. Now, 63. Okay, so 63. If we add up all the digits, which in this case is 6 and 3, we should have 9. 9 is a multiple of 3, so definitely this number can be divided by 3. Let's do that. Divided by 3, we should have 21. 21 can also be divided by 3. We all know that 3 times 7 is 21. Okay, so lastly, we're ending up with the quotient 7. Is 7 the final result? Yes. Why? Because we should always end up with a prime number. So 7 is a prime number, okay? Let's circle that to denote that we finished. So I will put a little circle around it, and I will say prime, okay? Which means we are done with the factorization. Good. So let's get back to the problem. What is the sum of all the distinct? You see the word distinct again, okay? So if a number appears several times, it only counts as 1, okay? Only counts on 1 appearance. It doesn't matter how many times it reappears. So let's identify what is the first distinct prime factor in our factorization procedure. It should be 2, right? Although it appears a lot of times, it should be 1, 2, 3, 4, 5 times, but it only counts as 1. So 2, what is the second number that is the prime factor? It's 3. It appeared twice, but only counts as 1. How about the third one, which is 7, okay? So these should be all the distinct prime numbers we have after doing the factorization procedure on 2016. And that's a very easy calculation, right? We should end up with one number, 12. Okay, good. So which option are we choosing? B. Actually, let's add one more step, okay? So after doing the prime factorization, we know that 2016 is equal to 2 to its 5th power times 3 to its 2nd power times 7. Okay, so that's just for for a supplement, okay, for better understanding. Again, the option should be B, and the approach is the exact same as the warm-up problem. Good, let's move on. So, exit ticket. What is the sum of the prime factors of 2010? Real or similar problem. So let's try to do performing the prime factorization on 2010, okay? So perform prime factorization, prime factorization on what number? Whatever number is given to us. So in this case, it's 2010. Is it even or is it odd number? Definitely it's a even number. So let's try divide it by the prime number 2. We should then ending up a quotient of 1005. Now, 1005, very, very special number because the last digit is 5. So it should be a multiple of 5. Then let's do that, divided by 5, which end up with 201, okay? 201, let's observe this digit, 201. How about let's add them up? We should have 2 plus 1, which is 3. 3 is a multiple of 3, so the original number 201 should be a multiple of 3. So, okay, let's do that. Divided by 3, we should have 67. Is 67 a prime number or not? It's a even number. It's an odd number, so definitely 2 will not work. 4, 6, these even factors will not work. How about 3? 6 plus 7, we get 13. Not a multiple of 3, so 3 doesn't work. 9 doesn't work. How about 7? So 7 times 9 is 63. Then we will have a remainder of 4. How about 8? 8 squared 64. We are leaving out 3 as a remainder. So you can try all these numbers and you will get the conclusion that 67 is prime. So when we are having the last quotient to be prime, we can stop the factorization. We are done at this point. And notice that this question is no longer asking for the word distinct. It's just asking for what? Change my color back to blue. It's just asking for the sum of the prime factors. So let's just add all these numbers up. So again, I will put 2010 is equals to 2 times 5 times 3 times 67. And let's add up all these 4 numbers. So I will put solution to know that this will give the final result. It should be 2 plus 5, which is 7, plus 3. 7 plus 3 is 10, plus 67. 10 plus 67, super easy, right? 77. Put a little box to denote as our final answer. So which option are we choosing? Definitely option C, okay? That's for this problem. And before we head into the last 2 challenging problem of today's live session, I would like to offer you a quick information explanation part. Okay, good. 好，然后还是说欢迎各位来到直播间的家长朋友们。然后大家可以看到我手有一本这个很厚的书，这个书就是我们的 AMC8 Book，AMC8 大宝典。刚才您看到的所有这次直播中出现的题目，它其实都是说来自于这本书。这本书最后一个章节叫做100 Tricky AMC8 Problems。然后这本书呢，它在编撰的时候，它包含了100多道易错题，然后还有50多道近10年的高频考点。可以大家打开给大家看一下。然后每个这个章节之前呢，比如说 number theory 之前，它会有一个这个 summary， 就先大概概括一下这个章节它运用到一些知识点。然后包括题目上，它其实在 warm up 前面会有引导，就非常适合小朋友在学过这个知识点之后自己去温故知新，举一反三，把这本书当做一个线下题库去使用然后另外一个非常值得推荐的地方呢，就是说这个书它所有题它会有分模块来进行，也就是比如说小朋友在考前他可能想专项加强某一个模块，他就可以直接打开书翻一下目录，比如说我想练一下书的模块，那我就翻到书的那一页，然后去把书的题都练了，就非常方便小朋友去进行一个考前的冲刺，他不用就相比于做整套试卷，它会更高效一些。这本书的原价是59美元。但我们现在做活动，您可以免费获取一本跟我手里这个一模一样的纸质版本。OK， 我们的活动分为2类，第一类就是说，如果您的孩子是新手，还没有参加过我们 Think Academy 的课程的话，那您可以添加屏幕下方这个微信， 也就是 think VIP 60，OK，the last two digit 60，没有空格。然后您加上这个微信之后呢，我会协助您去报名适合孩子的体验课，仅需$1。然后当孩子完成体验课之后，我们会有客服老师给您的地址寄送一本免费的纸质大宝典。然后对于老学员来说呢，如果您的孩子已经是我们 G4、G5 竞赛长期班的学员，那我们应该已经有老师在安排这本书的寄送，请您再耐心等待一下。然后如果您还没有收到，比如说已经过了一段时间了，也欢迎您添加下方屏幕的微信 think VIP 60，我会协助您尽快取得这本书。然后需要特别强调一下，我目前这个活动仅限小学高年级，也就是在暑期结束、秋季学期升入 Grade 3 to Grade 53到5年级的小朋友。好的，这就是关于我们这本书的一个介绍哈。Let's finish off today's problem solving session. Good. So the last two, they are challenging problems. So I will write down every details. Okay. So the first one is a warm up. It asking for a 2-digit positive integer. It's said to be coodly. It's a new word, coodly. If it is equal to the sum of its non-zero tens digit and the square of its unit digit. So follow the concept we are given. We should be able to write down the first step, which is, let me put color blue. Okay, it's already in blue. So let's suppose, I'll put here, suppose the number is xy. So x is 1 digit representing a tens digit. Y is the unit digit. I put a little bar around on top of it to denote that's a number. Okay, so since x is a tens digit, so we can put 10x. There's a question there. So 10x plus what? The unit digit is just y. And notice it is required what? The tens digit to be non-zero. So let's put a restriction on the value of x. X never be 0. So I think some key word is that integer is said to be coodly if it's equal to the sum of its non-zero tens digit and what? Excuse me. And the square of its unit digit. So by this information, we should be able to set up an equation. Good. So let me change my color for the second step. The second step, number 2, which is set up an equation to solve. Set up an equation to solve. So the number is equal to its sum. So let's first write down the number, which is 10x plus y, equal to the sum of its non-zero tens digit. In this case, our tens digit is just x. And the square, notice the word square, of its unit digit, which is y squared. Now we have a quadratic equation, right? You know the word quadratic. So when solving an equation like this, have more than one variable, we always want to put one variable on one. For example, we want to put all x variable on the left-hand side of the equality, and all the y variable or whatever the second variable on the right-hand side of the equality. So that's the approach. So let's do that by first minus x from both sides of the equation. Okay, so let's put a minus x here. And to make the equation balance still to be valid, we need to minus another x on the right-hand side. So the equation still holds. 10x minus x, we should have 9x plus y. And on the right-hand side, x and minus x, they cancel out. We are left with 9x plus y equals y squared. As I said, we always want to keep x on one side of the equation and y on the other side. Let's do that. We can achieve this easily by minus y on both sides of the equation. So we should have 9x minus y. So y are gone on the left-hand side, and there's a minus y, okay, on the right-hand side. Good. Now let's apply the distributive law of old friends. So the same factor they share should be y. So y times y is y squared, and 1 times y is y. So we should end up with 9x equals to 1, y times the difference of y minus 1. Now get back to the question. What is it asking? It's asking for how many 2-digit positive integers. So this means we need to figure out the value for x and y. So notice this. Y times the difference of y minus 1 equals to 9x. And x is what? X is a positive single-digit number. What can you learn from this? You can make the conclusion that y times the difference of y minus y is a multiple of 9. Okay, it can be divided perfectly by the number 9. Let's put this into a mathematical expression. So I will say, so the product y times the difference of y minus 1 must be a multiple of 9. Directly from the result of our equation, okay? Multiple, how to spell multiple? Multiple of 9. Cool. Then y is also a what? Single-digit positive number. So it's possible from 0 all the way to 9. 10 numbers, 10 possibility. Let's list them one by one. This is the quickest way, I think. So how about, let's think about y equals to 1, okay? So actually we can, let's start with y equals to 1. So if y is 1, by the way, y cannot be 0. Why we know y is not 0? Because if we put 0, y times y minus 1 will be negative, okay? We cannot have a negative number because it's asking for a 2-digit positive number. So let's start from 1. So that's a very good point. Starting from 1, then y times the difference of y minus 1 will be 0. Actually, this looks like it can be true, but if we do that, plug it into our result of calculation, we are having 9x equals to 0, right? Look, if y minus y times y is 0, then 9x must be 0, since the equality. Then this tells us x is 0. However, as we said, there's a restriction on the value of x. X never equals 0. So x is a non-zero 10th digit. So this case, it's not possible. Y equals 1 doesn't work. Let's put a little cross next to it to know this one is eliminated. And the second number we can try is y equals to 2. Good. So y equals to 2. This will give you y times y minus 1 equals to 2. Is 2 a multiple of 9? No. So this number doesn't satisfy the requirement. So another cross for y equal to 2, this case. How about y equals to 3? So let's get my pen ready. Okay, so y equals to 3. We will get 3 times 3 minus 1, which is 2. So we will get y times y minus 1 equals to 6. It doesn't work because 6 is not a multiple of 9. Y equals to 4. You should get 12. It's 4 times the difference of 4 and 1, which is 4 times 3, okay? So we should get 12. 12 doesn't work. How about y equals, wait, I'm zooming too much. So, okay, let me shift a little bit. So how about y equals to 5? 5 times the difference of 5 minus 1, you get 20. So y minus 1 equals 20. 20 doesn't work. Why? Not multiple of 9. So let's put all 3 of them with a red cross. Okay, good. And you can try it yourself, okay? It's a little bit time consuming when I'm trying to write it and explain it at the same time. But if you're trying only to write on your notes, it should be done in a few seconds. So it won't take that much time. So y equal to 6. 6 times 6 minus 1 is 30. So y times y minus 1 is 30. Definitely not a multiple of 9. It doesn't work. How about y equal to 7? Y equal to 7. Y times y minus 1 will be 42. 42 is not a multiple of 9, right? And last two will be y equals to 8, which will give you y times y minus 1 to be 56. 56 is a multiple of 7, it's a multiple of 8, but not a multiple of 9. Doesn't work. Lastly, the last digit we can try is what? Y equals to 9. So what number we get? Y times y minus 1 is 72. So y times y minus 1 is 72. 72 is definitely a multiple of 9. So we know after putting 8 cross, we finally have a number that satisfies the requirement. Good. So let's put a green check mark next to it. Good. So if y equals to 9, we are having 9x equals to 72. Here's my pen. I want it in blue. So I will put here. Then plug in what? Y equals to 9. Then we are having 9x equals to 9 times 8, which is 72. This will give you x equals to 8. Okay, I will pause to drink some water. Good. Now we have both x and y figured out. So we know the number, the only possible number xy is what? 80. And what is the unit digit? 9. Okay, so it's asking for how many? How many? Only one. Okay, so we are choosing option B. Good. So for a question like this, it's still that we are going to write out the expression of the numbers into letters. So each letter corresponds to one digit. Then after that, based on the given condition, we are usually being able to set up an equation to solve. So solving the equation will lead you to some possible cases, and you eliminate each case, one case at a time. And finally, those left out, which are the ones that satisfy the restrictions, should be give you the correct option to choose. Okay, so that's a general approach for a question like this. So this is a warm up. Let's try a problem that is directly derived from the 2016 AMC 8. It's question number 11, okay? So it should be a similar problem using the same approach. Let me get my pen ready. So the first step is what? Is to do the supposing. Suppose the number we are looking for. So at first, it must be a 2-digit. So let's suppose the number is xy. X is the 10th digit, y is the single digit or unit digit. So this one will give you 10 times x for the 10th digit and 1 times y for the unit digit. Good. So when the number is added to the number obtained by reversing its digit, okay, it's a little bit hard to understand, but let's read it again. Number is added. Wait, let me get my notes ready. So the number is added to the number obtained by what? Reversing its digit. The sum is 132. So based on this information, it's very enough for us to set up an equation to solve. Good. So set up the equation is always our second step, right? Set up the equation. We should be able to first identify what is the reverse number of x, y. It's basically swap the unit digit and 10th digit. That's it. Nothing too fancy, okay? So now y becomes a 10th digit, x becomes a unit digit. Still a little horizontal bar above to denote this is a number. Now we are going to set up the equation. So the number itself, 10x plus y, copy it down from the previous step, plus the reverse number on y-x bar. So that's saying we have 10y for the 10th digit, then plus 1x, 1 times x for the single digit. And their summation is 132. Now let's combine those terms that have the same factor, okay? 10x plus x, we should have 11x. 1y plus 10y, okay? Good, we have 11y. We observe a common factor, 132. Now, by observing the result on the left-hand side and the right-hand side of the equation, definitely we want to divide both sides by one number, by 11, okay? So dividing 11 on the left-hand side, we should have, okay, let me write one more step, the distributive law, equals to 132. So dividing both sides by 11, we should have x plus y equals to, what is 132 divided by 11? It should give you 12, okay? Be careful with the calculation. Now, we know the summation of x plus y, and the question is asking for how many. So let's try to count every possible ordered pairs of x, y that satisfy the fact their summation is 12. So that will be actually our third step. So I'll get my pen ready for yellow color. So let's first keep this in mind. Both x and y are what? Single digit numbers. Single digit. So digit. This is very useful because consider about which two numbers give you a summation of 12. You can say 1 plus 11, but can any of these number x, y to be 11 a double digit number? No, it will not work because we need x, y, the two number put together to be a two digit number. So each of them can only be a single digit number. So 1 plus 11, this kind of combination doesn't work. 2 plus 10, same reason, it cannot work. So we're starting from where? From 3, okay? So I will put another brief explanation. So that we need both x, y to be less than the smallest double digit number, which is 10, okay? Less than 10, so let's list all possible order pairs of what? Possible order pair of x, comma, y, where x plus y is 12. So as I said, we are starting from 3. So the first possible case is x equal to 3, y equals to 9, okay? Second is 4 plus which number gives you 12? 4 plus 8, good. Then it's 5 plus 7. Then I will start a new line here, 6 plus 6, right? The next one, we are actually reversing the value from x and y because we have 5 plus 7 for x, y, respectively. Then 7 plus y is a different combination because in this case, x is 7, y is 5. So this also counts. 7, 5 gives you 12. 8, 4 gives you 12. What is the last one? Last one is the reverse of 3, 9. So it's x equals 3, x equals 9, y equals 3. Good. So the question asking for how many two-digit numbers. So 39 is the first one, 48 the second one, 57 the third one. Then we have 66, 65, 84, and finally 93. So how many of them? Let's count it. 1, 2, 3, 4, 5, 6, 7. Which option is the correct one? We are going to choose option B, okay? So option B says 7 pairs. Let's also put a little box to denote this as our final answer. I will put a mark here. Okay, 7 pairs. So you see this kind of question, once you understand how to set up the equation, then you never leave all the possible cases. You count them one by one, case by case. You should be very comfortable when you see one of these problems on the exam, okay? All right, thank you. So lastly, before I call the end of today's session, there's brief information I would like to provide you guys. 欢迎大家来到今天我们的AMC 发100难题讲解直播间，欢迎大家大家可以看到我收了一本这个很厚的书，这个是我们的 AMC 8 book， 也就是 AMC 8大宝典。之前今天直播所用到的所有题目，实际上都出自这本书最后一个章节，也就是100 AMC Tricky Problems。这本书在编撰的时候呢，它收录了100加道易错题，还有50加个近10年的高频考点。也就是说，它非常适合小朋友拿来去作为一个赛前的冲刺的一个练习本。然后同时呢，我们的题目它是按照模块进行收录的。比如说，我随便翻开一页 ，OK， 比如说我就翻这页吧。这页你看它上面写了 Word Problems， 也就是说从这页往后，它可能有个10页，它都讲的是应用题，就是文字题。这样的话呢，就非常适合小朋友去找到自己可能不那么擅长的模块，进行一个专项强化，在考前完成查缺补漏的这样一个事情。同时呢，这本书还有一个非常好的地方，就是它每个章前面，就比如说 Word Problem 这章，它前面会有一个 Summary 就是告诉小朋友 ，OK， 这一章我们用到哪些知识点，比如它这个有一个 Identify Unknowns，Equality Relationships。Grouping method 就是说，小朋友在做题的时候可以先看一遍，然后有这么一个大概的概念，然后再去做题，这样效果就会更好。这本书售价是59美元，但我们现在做活动，您可以免费获得它。然后参与方式呢分为2类，第一个就是说，如果您的孩子是新生，还没有在 Think Academy 学习过，那非常欢迎您添加屏幕下方这个微信，也就是 Think VIP60， 没有空格。好，然后加上这个微信之后呢，我或者其他老师就会帮您推荐适合您孩子目前水平的填课。这个填课也仅需1美元，线上。然后当您的孩子完成填课之后呢，我们就有客服老师去安排这本纸质版大宝典跟我收益这本一模一样的大宝典去寄送到您所提供的地址。好，这对于新生。然后对于老生来说的话呢，如果您的孩子已经是我们 G4、G5 年级的竞赛长期班学员，这本书应该已经寄送给您了。然后 可能还有部分家长没有收到哈，那没关系，也欢迎您添加屏幕下方这个 Think VIP60 微信，我会协助您尽快取得这本书。然后最后要特别强调一下，就是目前我们这个活动仅限小学高年级，也就是暑期结束的秋季升入 G3 to G5、G3 到 G5的小朋友参加。好的今天就是我们的这个数论部分 live stream 的结束，然后再次欢迎大家来到我们的直播间。然后之后我会把今天直播的回放上传到视频号里，同时也会把我今天备课用的笔记提供给大家。All right, thank you so much for coming. Have a good rest of your days. I will see you guys next time.